right, so next one under the series, I mentioned about nilpotent groups. Okay, so a group is nilpotent if the upper central series ascend to G in a finite number of steps. Okay, and a group G is nilpotent of class K if and only if the upper central series stops at HK. Okay, so you have this upper central series. Right? You have this, you have a series, we call it H0, and then H1, and we call it, lastly, probably up. It can be infinite, but at the end, say this is G. Okay? Now the upper central series is called the upper central series if this is E1 and the second one is the center. Okay, and again we have this factor group is the center of G. If the shortest series is already from this to G, like you have seen in the diagram, right? We have seen this. This is actually the trivial subgroup. And the center is proper non-trivial. Proper non-trivial. Proper means it contains, it's not equal to. Okay, and this is the whole group. And center is always normal, right? And this is always normal. Okay, and 2 days ago we checked that this mod mod this is this, which is the center of this mod this. Okay, when I is 1, H1 mod, what am I saying? I is 1, I is 0. When I is 0, H0, okay, H1, H2, H0, H1, H2. So H1 mod H0 is equal to R180 mod R0. Okay, and yesterday again, 2 days ago, we have seen that this is isomorphic to this. Okay, so the formula is G mod E is isomorphic to G. Okay, so this side is this. This side, Z of G mod H0 is Z of D4 mod E, right? Again, this isomorphic to the center of D4. You can see it, right? Which is equal R180. Okay. So you see, this is equal. That is for I is 0. Now you have to change this I to I is 1. So when I is 1, I repeat actually from 2 days ago. When I is 1, H1 mod H0. When I is 1 is H2. When I is 1, H2 mod H1 is D4 mod R180. Okay, this is order 8, this is order 2. So the whole thing is order 4. Okay, and then I said this is isomorphic to Z4 or Z2 plus Z2. You can actually also find out what are the cosets and the quotient group, but it will take longer. So if you have prime, if the answer is prime, it's all cyclic. Okay, we have seen this before, right? All groups of prime order, they are cyclic, but this is not prime, it's 4, but the only possibility is this or this. This abelian. Okay, abelian. So this is that. What about the Z? Z D4 mod H1, right? Okay. So this is the center of D4 mod R180, right? Putting in the right part, okay? And the center of this, exactly this is this, which is abelian, and the center of something abelian is that thing, right? Okay, so you see this is equal to this, right? Since this is abelian. Okay, so if you don't see this, then you will get your factor group here. And then if you find the center, still, but it's a long way. Okay, I use shortcut. All right, so in this case, since our series is of length 2, because this is HK, 0, 1, 2, right? 0, 1, 2. Oh, I count this. So D4 is nilpotent of plus 2. Because they have 3 in the series, 2 subgroups in between, so it's 2. Okay. Next is every abelian group is nilpotent. Every abelian group is nilpotent. We don't really say the class, but actually, even you have this. The first one is H0, the second one is in the center, right? But if it's abelian, this is already the center. Okay, so actually every abelian group is nilpotent of class 1. But we don't normally say, we just say this. All finite P groups are nilpotent. Hey. Nak join kelas boleh juga. What was it? All finite P groups are nilpotent. What is actually a P group? Definition. G is a P group if the order of G is a power of P. Normally we put this way. Okay. So G is a P group if the order of G is a power of P. Now, example, D4 is a 2 group. Since the order of D4 is 8, which is 2 cube. Okay. Remark. Not all dihedral groups are P groups. Why? Because dihedral group has order 2n. And not all 2n is equal to 2 to the n. Okay? So, for example, when n is 3, 6 is not 2 power, right? So, only when n is even, right? Is 2 power. Not necessarily, because if you see n, for example, 2n, but we normally start with this is when n is 1, this one is a billion. This one is also a billion. We don't say about you know, n d to n is when we have a n gone, like d8, right? D n is 4. We're talking about 4 gone. 4 gone is a square, right? Okay, that's how I use 2n. So the n is the n gone, and we don't talk about 1 gone or 2 gone, 1 gone, 2 gone. So we normally start with a triangle. A triangle is 3 gone. So when we talk about dihedral group, normally we will start with 3. It's the smallest non-abelian group. Okay? Put in mind, don't go from here out here. If I ask you what is the smallest non-abelian group, what's the answer? D6, right? Or what do I use? D3 or D6? D4 or D8? I forgot already. Which one do I use? Do I use this or do I use this? Does she help?
D4.
Hmm?
D4.
D4. I use like this? Okay. Because I see like some of you like what? So meaning it's the end, right? Okay. some authors, they use D to N. But in my class, I think I use D4, right? For order 8. Okay, please correct me if I say something else, I put something else. Okay, you might be right, I might be wrong. So, okay, so D4, yeah, D4. D4 of order 8. So Dn of order 2n. And we normally start with D3. Okay, so if I ask you, what is the smallest non-abelian group? That will be D3 or S3, because D3 is isomorphic to S3. Did we do this? I think we did this, right? But D4 is not isomorphic to S4. We also did this because this is order 8, this is order 24. Okay, they cannot be isomorphic. This somehow, they both have order 6. Okay, then you can map. Okay, so if you do this, you get 2, 4, right? 8, 16, 32. Times 2, times 2, times 2, times 2. So this is okay, this is okay. Okay, this is okay, 8 is okay, right? But this is not okay. This is not okay. Meaning, this is not a P group, this is not a P group. It's 2 times 3, or 2 times 5, or 2 times 6, or 2 times 7. But if it's 2 times 8, it's okay. Okay? If it's 2 times anything a power of 2, it's okay. So, not all the hydrogroups are P groups. So, very easy. Something is a P group if the order is P to the K. And this is P is 2. What is P is 3. Okay, you can have G of order 3 to the power. Is a 3 group. Okay, let me ask you this question. Is 2 even or odd?
Even.
Is 2, number 2, is it even or odd? You have to unmute, then I can hear you. This is a math question plus English. Somebody, please say something. Actually, my professor asked us in class, I still remember. Tan, I haven't heard you for quite a while.
Even 2 is even.
2 is even. Okay, I would say 2 is also odd. Because 2 is the only even prime number. This is English odd. You know, in English, odd means strange. That's what I mean. So this is a joke of a mathematician. Don't take it too seriously. You all look so serious. I don't know. Okay, you know the prime numbers. This are all prime numbers, right? You see, this is all prime numbers. Prime numbers are numbers that the factors are only 1 and itself. Okay, only 1 and itself. So why 1 is not a prime number? You all have degree in mathematics, and some of you have master already in mathematics. Okay, Hassan. Is Hassan the only one that has master in mathematics in this class? Hassan? Don't hide, Hassan. I cannot see you. Hassan, you have to remind me. I have to focus. I forgot already, Hassan, from Saturday.
Okay.
So the question is, why 1 is not a prime number?
The prime number has only two divisors, one and the number itself.
A number is prime if the only divisors are 1
And
and itself,
itself.
right?
Yes.
1 have factors.
Dividing all the numbers.
I will go to you after this, yeah? Because Hassan said a number is prime if the only divisors are 1 and itself. But the divisors for 1 is 1 and itself. So according to
Itself.
that, okay,
No, itself means not one.
didn't say not 1. It didn't say different than 1 in the definition, right? Mtinan, you were saying something, right?
Number 1, division on all numbers.
1 is a factor of all numbers.
Yeah.
But why? Why it cannot be prime?
Because it has one positive divisor.
We are used to having starting prime number from 2, right? Don't tell me that 1 is not prime because my teachers start prime number from 2. Because you are given that from you are little, right? Prime number is 2. There is a reason why 1 is not prime. By definition, after this you can Google. What is the definition of prime number? Prime numbers are numbers which can be only divisible by 1 and itself. Just that. And sometimes authors, they said prime number is a number bigger than 1, right? To make it easy, they said that. But actually, why? Is because of the fundamental theorem of arithmetic. Can you Google this and tell me what it says? If you don't use your phone, can you Google? Hannah, you Google and read.
It said here, every integer greater than 1 either is a prime number itself or can be represented as the product of prime numbers.
Okay, so actually the history started from that. Every number can be written as a product of powers of primes. Or not powers, as a product of prime numbers. Actually, in a unique way, not according to orders. Again, not according to orders. Meaning, I haven't even finished with this theorem, right? It's the long story. Okay. Like, let me start with, that is 6. 6 is 2 times 3, or 3 times 2. If you have 12, 12 is 2 times 2 times 3. There is no other way unless you do the 2, 3, right? It has to be 2 of 2 and 1 of 3. Okay, prime, because this is prime. If 1 were a prime, you can write 12 as, right? You can also write 12 as, see what happened? It's not anymore unique. So this is the reason why 1 is not prime, because then it will violate the fundamental theorem of arithmetic. Teacher don't teach this in school because the student won't understand. Hassan, this is actually the reason why 1 is not prime. Okay, so then the other mathematicians start the definition to be bigger than 1. Even this fundamental theorem, we want it to be bigger than 1. We don't want to include 1. And this is the real reason, okay? Because every number can be written as a product of prime numbers in a unique way. And having 1 as a prime will violate this theorem. That's the reason. So we say that prime numbers we have 2, 3, and so on. And back to my question, 2 is actually an even number, but to me it's odd, or it's actually very odd because it's the only even prime number, right? Don't get confused. The odd one is the weird one, the strange one, the English odd. Okay, not the can be divided by 2 odd. And that is why people tend to ignore or not doing anything with prime 2. And that is also a reason why I had my research, my scope of PhD. People tend to not doing research on the 2 group because having prime equals to 2 makes it very complicated. Okay, when I'm classifying all the groups, turn out to be something like this. There's something inside when I do the calculation. I have this combinatorial, all right? And when P is 2, then there's something happening. If P is prime, like 3, then you cannot cancel in one way. So it's a long story, but I'm not gonna say that. Okay, back to this. Why all finite P groups are nilpotent? Because we can start with E, okay, and then this is H now, right? And then we can have H1 and then up until HK, which is G. If this is order P to the K, if this is order 1, I can have 1 with this order. Okay? Because if you have like D4 of order 8, you can have something of order 4 here, right? You you can have something of order 2 here. You can also have the trivial one. And divide, you divide, it's 2, it's P. Okay, so for order dividing this, you can have a subgroup of that order. And that's why when you take the quotient, right, is equal to P. This divide that, is all equal to P. And so these are all cyclic. Hence, abelian. Okay, and if it's abelian, then the next stage is to find the center. Okay, and the center of something abelian is the whole thing. So you go back and then you find the proof. It's very famous. It's a very famous property that all finite P groups, they are nilpotent. Okay. In the last class, I asked you to find something, right? Hannah? I said, this is your homework. It's not assignment. I remember. What is the question?
The first one is cyclic group of 1, 2, normal to S4.
Okay. You remember or not? Did you find it or not? No. So, Hannah, did you try or not? Or you just copy the question?
I tried, but I'm not sure is it correct or
Did
not.
you find all the cosets?
No.
If you try using the x inverse hx is in h, that is one way. You have to try for all. If you want to double check, you can do with the coset. But you will get like quite a lot of coset. But in each one, there are only 2 elements, right?
Yes.
What's the second question?
Is V4 normal to S4?
Okay. And you try using?
Using the H inverse as X inverse HX too.
Are you able to show they're all in H? Or in V?
Yes.
Okay. So make sure, yeah, the others, if you haven't tried, make sure you try and show the V4, for example, is normal to S4. Who knows that is the question for your test too, right? Solvable groups. My last topic for today. Some books or authors use solvable. Okay, it's not a medicine, yeah, which soluble. It's a group called solvable. A group is called solvable if it has a subnormal series whose factor groups are all abelian. Okay, just now I mentioned about the quotient group has order P, which is cyclic, which is abelian. So then we know that all abelian groups are solvable and all nilpotent groups are also solvable. Let me write it out before I stop. A group G is called solvable. This does not mean that there is a solution of anything, right? It's just solvable. If it has a subnormal series whose factor groups are all abelian. That is, they are this 2H here like before? Such that GI minus 1 is normal in GI. This is normal in this is normal in this is normal, this is normal, right? Like the sort normal series. And additional is GI plus 1 mod GI is abelian. Not only the one is normal to the next one, but the factor group of the bigger one mod the previous one is abelian. So if the group is abelian, all the subgroups are normal. So this clearly show that it's solvable because even the factor group is abelian. Okay, try homework. Hannah, you didn't even put the homework in the WhatsApp group of the class last time. Read through examples of solvable groups. That is and find as many examples of solvable groups. I remember when I was doing a PhD, there's another PhD student working on solvable groups. So the scope is solvable groups. It can be one PhD. Okay. Now for your assignment, just do it first. Don't hand in yet. You can try all. Okay. Or maybe I can just say, do exercise 9, do all for next week, next Wednesday. Assignment number? Hannah? Number 5. So assignment number 5, only 4 questions, but in that 4 questions, there are examples in that question. Let's like example 1, 2, 3, 4, 5, 6. Okay, I will stop here. I have another meeting. Okay, just any question maybe before we take our group photo?